And after confirming the first case of the Omicron variant of COVID-19, Kerala is running genome sequencing tests on 30 more suspected samples at the Rajiv Gandhi Centre for Biotechnology in Thiruvananthapuram. NDTV's Sneha Koshi reports from inside the Omicron testing centre.
We are currently at the Rajiv Gandhi Centre for Biotechnology in Thiruvananthapuram, and this is the laboratory section where all the samples are being tested. This is where you're getting COVID-19 positive samples as well as Omicron suspect samples, and here is where the preparation for the testing begins at around, which itself takes around 8 hours. Joining us right now is the scientist, the main scientist who is heading this entire division, Dr. Radhakrishnan. Kerala has confirmed one case of Omicron. However, there are around 4 primary contacts of that person, including a co-passenger, who have tested positive and are being right now tested for Omicron. Dr. Radhakrishnan, so what is the status currently post the Omicron confirmation in Kerala?
We have got only 1 positive cases as of now, and we have 4, as what you said, we have only 4 more cases which are being suspected to be positive because they were in very close contact with the person who was tested positive. We have another around 30 samples which have come from patients who have tested COVID positive at the airport, and we will analyze.
Various airports.
Sorry?
Various airports.
Various airports across Kerala.
From the time you receive the sample till it is confirmed whether it is an Omicron or not, how many hours does it take?
To know whether it is Omicron or not, we have to do a next generation sequencing. So what we currently estimate is around 72 hours, but most of the time we could report it in 48 hours. Last time when we did, we had only 8 samples, so we could stop the reaction in 24 hours.
So 96 samples you can put at one time. On one fossil, in one machine.
One machine. And the other machines can do 272 samples.
Your total capacity is 3,000 per day.
Exactly. Because once the run is over, we can take it out, put it for computational analysis, and reload the same machine.
So this is the room where your RNA, after being converted to cDNA, is then amplified. This is where you get a primary sense. There's barcodes which are given, and all of them are brought together. Dr. Radhakrishnan, my question to you is, so after all this preparation for 8 hours that have gone in, then comes in the flossets, where one flosset costs
1.25 lakhs.
Can you show that to us?
This is how a flow cell looks like basically.
So this is a machine.
No, this is only a flow cell. Machine is this.
This is the machine. So these are very, very small.
Very small. It is
This is right.
Portable. It comes with its own. This is the calibrator for it.
Right.
So we have a calibrator on it. So this is a test flow cell which we use to calibrate this machine before every run.
Right.
It's nothing but an ordinary chip onto it. So once you turn on this, once you connect it to the computer and turn this on, you use this chip to initially calibrate this machine. Once that is done,
and this on one flosset, how many samples can be tested?
96 samples can go into a single flow cell.
Right.
Okay, so initially you open this up and through this hole you flush it, flush the reagents in it. Then once that flushing is done, then we open this thing up, add samples through this small hole. Okay, that's where we add all the pooled 96 samples.
Right.
So every sample is pooled together and add around 80 microliter of the pooled sample onto this. Close this thing. Once this is closed, it goes into this machine.
So my question, Dr. Radhakrishnan, is it that we are taking a lot of time in India for these genomic sequencing to be done, or is this the standard? Because if you look in some other countries like Denmark or UK, as some are saying, that the numbers, the quantum of testing is much higher. So is there an issue here? What if the cases explode, or what if there are a larger number of cases?
No, the total genome sequencing capacity of India has increased tremendously. Once this INSACOG or the consortium, once it has come, we have so many institutes, both DVT, CSIR and individual institutes like the NIMHANS in Bangalore. All those people, CDFD Hyderabad, all of these institutes have started, they all have the sequencing capacity. They were not being used for COVID research or COVID testing. Now all those resources, even we used to do sequencing, but entirely for cancer markers. So we stopped all those things, or we gave specific timing for the patients for routine markers, and we shifted all our energy onto doing COVID tests. So even if the cases go up, the machines which we have in India is currently not being utilized to its full capacity, because those machines need around 272 samples per run.
So you are saying you have a capacity of around 3,000 per day. Now 3,000 per day, if you're testing 3,000 samples per day, you're looking at the results in a minimum period of how long?
72 hours.
72 hours plus the time that will take for bioinformatics, which would be another 24 hours?
24 hours, it depends. It may go up to 48 hours also. So, but this is for the...
Is this too slow, or is this the standard world
This is
across?
very much the standard. There are no other technologies in the world which exist which can do faster than this. Because none of these technologies which we currently use in India are indigenously developed. So whatever system the US has is the same system India has.